Hello my people. So today let me show you how we can do maneuver in R. Remember, maneuver stands for multivariate analysis of variance, and it is just an extension of ANOVA that allows you to test whether groups differ on multiple dependent variables simultaneously. For example, we can have dependent variables like age and BMI, and we are trying to see how gender differ on those two multiple dependent variables simultaneously. That is where the maneuver comes in. And I want to illustrate how we can do maneuver in R using the stroke data. So let's start. So the first step is to load the packages. That is the tidyverse for data manipulation and also janitor for data cleaning. The next step is to load the data. That is a stroke data, which is a CSV file. The next step is to view the structure of the data. So look at this. We have this number of rows and also 12 columns. Among the 12 columns, we have gender, age, hypertension, heart disease, sever married, and so on. So we can decide to look, for example, like a group like work type. Then we see how it's differing in terms of average glucose level and also BMI. Now the appropriate statistical test will be the maneuver. So the next step is to do data preparation, where we just ensure that all character variables are converted back to factors, like that. Then now the last step is now to perform the maneuver, multivariate analysis of variance maneuver. And under the maneuver, we can just call it model is equals to, the function is always maneuver into bracket, then we use cbind to combine the two dependent variables, that is the BMI and also the average glucose level, like that. Then we move outside the bracket, we'll tilde with the group, that is the work type. Then after that, we just have to mention the data. So data is equals to, I just call it data, then I run. After running it, now we do the summary. Under the summary, we just write summary is equals to summary into model, then we define the test statistic. It is always called Wilks. The test statistic for maneuver, Wilks, like that. Then we run, then it's going to give us the output. As you can see now, this is the output of the maneuver. When you look at the p-value, you look at the p-value, notice that the p-value is less than 0.05, meaning this p-value, this value is highly significant. It means that work type has a statistically significant multivariate effect on the combined outcome of BMI and also average glucose level. So for example, this you can say that the maneuver test using the Wilks lambda. When I say Wilks, this is now the test statistic. The Wilks lambda indicates a statistically significant effect of work type on the combination of BMI and average glucose level. Yeah, so this suggests that individuals' work types are associated with the differences in both BMI and average glucose level when combined together. So that is the concept of the multivariate analysis of variance. This is just an extension of ANOVA that allows you to test whether groups differ on multiple dependent variables simultaneously. Yeah, so that is all about maneuver.